Happy Wednesday, everybody. Today we are learning about our last set of identities. So we can title our notes 5-5 Day 3. And today we're doing evaluating using half-angle identities. And today is April 29th, my mother's birthday. Okay, so first things first, let's write down those identities. Half angle. I would write it both in your notes and also on that note card that hopefully you're all, if I can spell correct, identities. And on a note card. Okay, so the first one is going to be sine of theta over 2. So half of an angle, theta. And that's going to be equal to plus or minus, my g's in the way, 1 minus cosine of theta all over 2. Cosine of theta over 2 is equal to plus or minus the square root of 1 plus cosine of theta over 2. And then we've got 3 for tangent. So the first one is plus or minus the square root of 1 minus cosine of theta divided by 1 plus cosine of theta. Then we have tangent of theta divided by 2 equals 1 minus cosine of theta over sine of theta. I'm going to put a star next to this one. And the last one is tangent of theta over 2 equals sine of theta over 1 plus cosine of theta. So make sure you have all of these on a note card. I starred this tangent half-angle identity because there's 3, so you have 3 options. One is plus or minus, so I'm going to get to plus or minuses in a second. But these two aren't. And this one only has one thing in the denominator, just one term. So if you have the opportunity to use this formula, I recommend using it. Sometimes it's less work. Now getting to, what color? I guess I'll use pink. The pluses and minuses, I feel like that's hard to see. For the pluses and minuses, you're going to have to decide in the beginning of your problem if you want it to be plus or minus. So to determine the sine of your theta over 2, your half angle, you want to look at the quadrant theta over 2 is in and decide. So it all depends on the quadrant that theta over 2, not theta, theta over 2 is in. Okay, let's move on to an example. So if I ask you to find the exact value of cosine of 22, here I'm going to rewrite down here, but cosine of 22.5 degrees. So first thing you could do is try to use a sum or difference identity, but because it's a half angle, or it's 22.5, there's a decimal, you can't do that. So we can rewrite this as a half angle. So all you do is take this angle and multiply it by 2, which is 45. So we're just rewriting this 22.5 as 45 halves. So it's the exact same number, but now it's a half angle. So now that it's a half angle identity, or half angle, we can use the half angle identity. So that's going to look like, for cosine, it's plus or minus the square root of 1 plus cosine of theta. Okay, going back up. So a lot of highlighting. This theta is only here. Notice it's not theta over 2. So 45 is what's going to go right here. All divided by 2. Now I need to decide if it's positive or negative. So remember, I'm going to look at theta over 2. And because it's 22.5 cosine, it's going to be positive. And now we go from there. So keeping everything positive, we're going to have 1 plus, what's cosine of 45? Root 2 over 2. I'm going to rewrite this, because you know I don't like a fraction within a fraction, as the square root of, so this is 2 over 2, remember, so 2 plus root 2 all over 2, divided by 2. Same thing as multiplying by 1/2. Don't forget your square root. Students tend to drop that. So this is the same as the square root of 2 plus root 2 all over 4. And then technically the square root is in the numerator and denominator. I'll show an extra line of work. Oops. So when I simplify this, my final answer is going to be the square root of 2 plus root 2 all over 2, because the square root of 4. And we are done. So now I'd like you guys to try this problem. Same idea, but I'm going to give you tangent of pi over 12. So try to do this using the half angle identities, not sum and difference, half angle. Pause the video and then hit play when you're ready to go over it. Okay, so hopefully you've finished. So first step is to rewrite this as a half angle. Since it's a fraction, I want to use 1/2, right, because I'm divided by 2. And pi over 12 is 1/2 times pi over 6. So that means pi over 6 is my theta. So now is when you get 3 options. There's 3 tangent identities for half angle. So I'm going to choose the one that I told you to start, because there's one term in the denominator, so it's going to be, in my opinion, easier. So we're now going to rewrite this as 1 minus cosine of theta, which remember is the pi over 6, divided by sine of theta, which is pi over 6. Now we're going to use what we know from the unit circle. So we have in the numerator 1 minus cosine of pi over 6 is root 3 over 2. And we're dividing by sine of pi over 6, which is the same as 1/2. And I knew we were going to have a fraction and a fraction, so I already separated it. Now I'm going to rewrite this. So it'll be 2 minus root 3 over 2 times 2. If you want, you can throw that over 1 in. And then because I'm multiplying, these are actually just going to cancel. So my final answer is just 2 minus root 3. And we are done. So hopefully that's what you got. Now we're going to do one more example. And it's going to be a solving problem. Okay, solve sine squared of x over 2 equals cosine squared of x over 2 if x is between 0 and 2 pi. So, first things first, because we have half angles, we want to replace these using the half angle identities, and we're trying to solve for x. And then another thing to take note of, notice that it's squared. So when I'm rewriting this, sine of x over 2 is plus or minus the square root, so just using my identity, of 1 minus cosine of x, all divided by 2. And the cosine identity is plus or minus the square root of 1 plus cosine of x all over 2. Now, I told you to be careful because the original was squared, so we're starting this off. I guess I should do it in the same color since we're starting it off. It's already squared, so I'm just throwing this in parentheses. Now, if it wasn't already squared, you would need to square it because we want to get rid of the radical, but it's already squared, so we don't have to worry about it. So then we are left with 1 minus cosine of x over 2 and 1 plus cosine of x over 2. If I multiply both sides by 2, my 2's are going to cancel. So I'm left with 1 minus cosine of x equals 1 plus cosine of x. If I move everything to the right side, 1 minus 1 is 0, and then cosine plus cosine is 2 cosine of x. I want cosine by itself, so I'm going to divide. So I've got 0 equals cosine of x. And I'm just asking myself what values of x give me 0. That's going to be pi over 2 and 3 pi over 2. And remember, pay attention to the interval you were given originally. Now, because it was already squared, I don't actually have to check my work. However, remember, anytime you have to square a problem, you need to check for extraneous solutions. So, hopefully that makes sense. There's some problems in your homework that you have to square on your own, so you'll get some practice there. And that's it for this week. Tomorrow we're going to be reviewing, and tomorrow we also have flex time. So if you have any questions, feel free to log on to flex tomorrow.